All right, so today we're going to talk about something called permutations and combinations. As a reminder, make sure you've got your notes ready, printed out, or set up in your notebook. As a reminder, you're going to attach 9.6 number 36, the presentation, as the thing you turn in on this assignment, and then you've got this additional practice to help you master these concepts. So, the first thing we're going to talk about, when we talk about permutations and combinations, I'm sure some of you are wondering what that means, but what we want to start with is both of them involve these things called factorials, which some of you might be familiar with. Now, remember, when you see the word factor like this, that means we're talking about multiplication. Now, with a factor, what this means is the product of consecutive numbers, and it's written with an exclamation point. So you might see something like this as some number, so 7, and with an exclamation point after it, like we see here 9 with an exclamation point, and we read that as n factorial or 9 factorial here. And what it means is that it's, again, the product of the consecutive numbers up to there. So it'd be consecutive 1 times 2 times 3 times 4, all the way out to whatever that number is, n. So if I'm looking at number 1, the numerator here is 9 factorial, so that becomes 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9. And that's the numerator there. For 9 factorial, the 9 tells us when we stop in our list of consecutive numbers. One weird thing, sort of like with exponents, is that when you have a 0 plugged in, it equals 1. So something to make sure that you remember, 0 factorial is equal to 1, just like with exponents where something to the 0 power is equal to 1. Now, when we calculate with factorials, the nice thing is I don't want to multiply all these together, but you'll often see factorials in fractions. So that is over 8 factorial, because we're still following PEMDAS, meaning that we're doing our parentheses first. So we have 9 factorial over 8 factorial, and when we write that out, 9 factorial over 8 factorial, you'll notice that a ton of numbers cancel out, because we've got 1 times 2 all the way out to 8 here and here, and so since they're multiplied, they all cancel out, and we're left with just 9 over 1, or 9. So a lot of times our factorial problems will look complicated, but we can do a lot of canceling because they're written as fractions. Now, permutations use factorials to calculate and to answer problems like what we see in number 2. So 5 athletes enter a contest. How many different finishing orders are possible? So how many ways are there for these people to finish in this order? And this is a permutations problem, which is about the number of orders of outcomes. So how many ways could things be arranged? How many ways could we put books on a shelf? How many different seating charts could we make? These are all examples of permutations. So how many ways to order something out of something? We use different variables for this. So k would be the part out of n is the whole. So how many ways to order k objects out of n total? And there's a formula for this. So the number of ways to order k objects out of the n total is using factorials, n factorial over, parentheses, n minus k factorial. So really similar to what we just saw in number 1. So what we want to do is, knowing that formula, we want to recognize that it's a permutation, and then just using our deductive reasoning skills, figure out what n equals and what k equals. N is usually easier. It's like, what is the total number of people participating? What's the total number of books we want to put on a shelf? The total number of students in the classroom that we want to put in a seating chart. So in this case, we've got 5 athletes in a contest. So n is 5, because that's our total. And now with k, that usually takes a little bit more logic. In this case, it's actually going to be 5 as well, because we're saying that everyone's going to finish. So n is our total, and then we want to arrange 5 people from that total, because again, we assume that everyone finishes and there's not some sort of catastrophe where someone breaks their leg halfway through. if there is something like that, they will definitely tell you in the problem. So knowing that is the formula, we can plug it in here, meaning that n factorial is 5 factorial over parentheses n minus k, and we're left with 5 factorial over 0 factorial. If you remember from our factorial definitions, we know that 0 factorial is 1, and then 5 factorial is 1 times 2 times 3 times 4 times 5. And cancels if we want to. 2 times 3 times 4 times 5 is 120. So there are 120 different ways that these 5 athletes could finish their competition. Now, if you remember from the objectives, there's permutations and there's combinations. So combinations is the number of outcomes total, but where order doesn't actually matter. So it's just about choosing, a certain number out of the total. So if you think about the sandwiches, you were just choosing a topping out of the total. What order you picked it in didn't actually matter. You're still going to make the sandwich the same way if you pick the fillings first or you pick the bread first from yesterday's lesson. Which is still going to use this whole idea of K and N. So we're choosing part out of a total where order doesn't matter. And you've got to look for context clues. They will be very specific in the problem. So if we're looking here, I have to choose. So you'll notice the word choose. You're like, combination. 2 students to go to Mr. Polofsky's office from a class of 30. How many different pairs can I pick? So even if I didn't use the word choose, you could be like, well, if I pick 2 kids, it doesn't matter if I pick Timmy or Betsy first. They're both going to go to the office together. It doesn't matter what order. But if you see the word choose, that means that it's going to be a combination. And the formula for the combination is similar. It's n factorial over n minus k factorial parentheses, but there's also a k factorial here. So there's just that little extra bit in the denominator, and that's the difference between a combination and a permutation. So again, we're going to make sure that we're identifying our n and our k correctly. In here, our total, we have 30 students, and we are choosing 2 of them. So we have our n and our k, our total, and our part. And we're going to plug that in to say 30 factorial over 2 factorial and 30 minus 2. Now, some of you might be thinking, like, 30 factorial is something I don't want to do by hand, right? 1 times 2 times 3 times all the way out to 28, 29, 30. Like, I don't want to multiply all those together. Miss Ross doesn't either. But if we expand that out, we then also get 1 times 2 from the 2 factorial here. 30 minus 2 is 28 factorial. So you get 1 times 2 times 3 times ... all the way out to 28. So what I would hope you notice, like in number 1, you get to cancel out a bunch of numbers because they're all multiplied. So cancels, and you're left with the much more straightforward problem of 29 times 30 over 1 times 2. This is 2 and 30 cancel out, so we're just really looking at 29 times 15. It's not like the easiest problem in the world, but it's pretty straightforward, and if you have a calculator or even by hand, you should get 435 different pairs. So remember that you're going to turn in this problem here on this assignment, and I'll be available for questions on Zoom or in the comments below. Talk to you later. Bye.